Hi everyone, welcome back to Dragonfly Engineering. So April and I have a new project that we're working on, and it is going to be a part picking robot for an injection molding machine. So this robot, its purpose in life, or has been in the past, is that it mounts to the platen of the injection molding machine. You can see over here, this is our dual shot molding machine. So up there is a mounting utility for mounting a part picking robot, which is what this is. And this is basically an X, Y, and Z travel robot. And what it does is it will reach down inside of a molding machine area where the molds are and pull the part out. And then tell the molding machine, okay, the part's out, so mold your next part. And usually the part comes over outside of the molding machine, drops down to a conveyor belt or a bucket of finished parts, or to some robot that then takes the part off and does more work. So for those who have watched our channel for a little bit, you probably saw that April and I went to a molding company in the San Francisco Bay Area that was closing. Basically the owner retired, and he was selling off all his assets. Well, in the back alley, I saw that this Cartesian robot was sitting in a heap, and I asked the guy, can I have it? And he says, yes, you can have it scrap, no cost or anything. So I think there's maybe a clip of us loading this robot onto the trailer to take it out of there. Low as you can. But anyway, the robot was dead. Everything was worn out on it. It's air actuated. So this air cylinder right here is what used to push this Y axis, or I guess this is X and this is Y. So this carriage would slide back and forth with that long air cylinder, which is basically the length of this travel. And also there's an air cylinder for this axis and an air cylinder for the Z axis. Well, all of that apparently was completely worn out because it was thrown in the alley behind the building. So I bought it, or I acquired it basically just for the frame. And April and I are going to tear out all of this old pneumatics control system. We're going to keep as much of the actual linear rails as we can, which look to be in reasonably good shape. As you can see, it's kind of been torn up a bit. For instance, this bracket broke off, this box is bent, and a lot of the actual controls have been totally destroyed. For instance, like at some point, something sat on this hose and cut it in half, and other things are just busted off.
Ooh,
so,
wow, look at
yeah.
that.
Anyway, but the value is the actual weldment, which is the frame for the XYZ travel. So we can walk over here and take a look at some of more of the funk. This carcass, when it was basically dead, was very difficult to move with the forklift because it could still slide back and forth. So it was like this weird 3-axis heavy steel structure that had a shifting balance point continually. So you'd lift it up and this whole axis would move all the way to the other end, and then the thing would fall off. So there was a few times where I wound up just dragging this carcass back into the shop, you know, along concrete. So there's just like concrete rub and stuff everywhere. This structure here, which actually totally broke off. In fact, there it's still breaking off. Used to be the Z axis, which is another air cylinder, and then these rod bearings. But you know, everything was worn out. So I wasn't too worried when the Z axis broke off of this carcass during the operations of forklifting and moving it around, because I was gonna get rid of all of this anyway. And it really broke. I mean, there's like, you can see, you can do failure analysis basically of some of the structure where like this plate here, you can see how it broke because they drilled too many holes in it and it snapped off. But anyway, so the plan is that I am going to do the mechanical work to upgrade this carcass with electric motors and belt drives. And April's mission is going to be to build the control box with the electronics, the motor controllers, and write the software using a Raspberry Pi computer as the platform, and probably doing Python coding, maybe vibe coding with the internet, or oh, you're just going to straight up code it? She's giving me a no to the vibe code. So April's just going to write the full drive software for this robot. And so this will be a mini series. Hopefully it'll take us about a month to get this thing running. And our plan is probably to load this picking robot. Again, so this is the one axis that goes across the platen of the molding machine. This axis reaches into where the molds are. So imagine my two hands are the two molds. And then a Z-axis is going to come up and down, which used to be this structure with grippers or suction cups or whatever end effector we decide to have. And it's going to cycle every time the molding machine opens, and it's going to, this thing's job is to pull apart and stick it on a conveyor or give it to another robot. So it should be fun. Hopefully you guys enjoy our deconstruction of this mess.
Or rehabilitation.
Yes, a rehab of this complete disaster of an instrument. For instance, this sums it up. I think this used to be the travel limit lead screw, and it's all bent, and basically we just had to cut it off.
I think you should put the paper towel back on so that it looks like a
oh
paper
yeah
roll.
And to keep ourselves from whacking our heads,
these are head whack.
We stick a paper towel roll onto the end of that, and we got a nice foam structure here. We did, with the help of a friend of ours, we did mount this robot onto the table. So we drilled and bolted this flange onto this heavy steel table. That way we could work on it. Otherwise, this thing, because it's such a strange structure, just winds up being a heap on the floor, and you can't really work it. So we did have to mount the robot to this project table, and that was a big step.
Right.
Also, we've been arranging the shop and cleaning it up. Some of the background views that you may have seen in the past is there was no more room to walk in here. So another mission is that we are organizing the whole shop. All of these molds that I got for free, we're going to take apart and show, probably have another series of just opening up old extinct molds to see what's inside. And the dual shot molding machine is going to move to this area once we clean up the rest of this excess gear. And then that will give us the ability for the forklift to access the wall storage rack system over there to further organize this workspace. So a lot of activity is going on right now. Also, we moved the 3D printer over here so that it's not so smelly in the office, and just little things like that. So let's take a look at April's control box. She's starting to lay out the major components, and we're figuring out airflow and where to mount the control box and all of that.
Okay. So we got this control box used. So it's already got some holes in it from a previous owner's plan. But we're going to repurpose this control box to go on to the blue Cartesian XY robot, which is going to be sitting on top of the molding machine.
Okay.
So that's a very important thing, because if you have a control box on top of a molding machine, there's a lot of heat coming out of the nozzles of the molding machine. Now we've decided, I've started to label stuff, that this is the bottom. This is going to be the top.
All right.
Those
are the pre-existing holes?
Pre-existing holes, like any hole that you see is pre-existing. So it's got an opening, and we're going to look through the window. But we've also got our inlets that we've figured out to be 4.1 inch, and we're going to do a pair of them. Now, most of the time, so we're going to have the fan on the right side. We're going to have the inlets on the left side. Most of the time, people try to do a V air plan. Like, so basically, air is
the airflow?
intake.
Okay.
Yeah, airflow is intake from the bottom and the top both. We need to, so that our box is not Swiss cheese, we need to put our inlets a little bit closer together. There's holes underneath these templates.
And these are existing holes that you put mini filters in, which is kind of cool.
Right. I ad-libbed these filters.
Nice.
But the thing is if you're dealing, like our injection molding machine has a lot of dirt and plastic particulate.
Yeah.
So putting too many holes in a control box that's going to be directly above an injection molder is not what you want to do.
Yeah, and that vacuum loader just creates...
Right.
It accumulates dust from the plastic being loaded into the molding machine, too.
Right. So our overall plan is going to be 4.1 by 4.1 times 2
air inlets.
Air inlets with a metal mesh.
All right.
And then we're going to be running this NBM, what is this, about a 5-inch diameter fan. So this is a pretty beefy fan. It's not, as you can see, I've got a template. And I'm just putting the fan in there to hold it.
And we're going to drill around the hole. Right.
Yeah.
Spot that we decided.
Or do you want to move the paper?
No, I'll just drill through it here. Okay.
Okay, so I got a mark.
I may have to hold the back of the spot. All right, here goes everything. Oh, actually, I'll use the table as a drill stop. All right, this is where it gets crazy. Should probably do the torque limiting for now. I'm angling the hole saw slightly so that we don't have all the teeth grab the plastic at once. Kind of a torque limiting scheme. There, we'll go to full torque. Here we go.
Ooh, look at that.
All right.
Nice.
It's a nice clean hole.
Woo, that's a beauty.
The big hole saw. All right. We can probably use that for something.
Yeah. Coaster. Just
There you go. Have to clean it up. There's a deburr tool.
we're gonna hole saw it, and then here's electrical that we will hook up internally. So, so let's just talk about. We'll talk about the motor drivers. This is a S2 SVD 20, and we're gonna, XYZ, however it turns out. It's really important.
And these are ones that we had in surplus because I bought these during the whole tariff thing, and then the ones I really wanted for the laser cutter became available. So these are actually excess in our inventory.
So the way that these drivers work is now I have this fan oriented towards the box fan, right? And you remember this is air comes in and moves out
Yeah.
the fan.
Mhm.
So why would I have a fan pointed towards another fan, right?
Mhm.
Not terribly intuitive, but the thing is this fan will suck air in and blow it across these fins.
Mhm.
So you actually having the two fans pointing towards each other is okay. The other thing to know is that this is an LED, and this is basically kind of how you tell the driver that it's configured, kind of like a dip switch on different other drivers.
Okay.
So I will need to be programming these later once we get
Okay.
power service. And what we're going to, the reason that we're going to program them is that we're going to be using a 60 ohm, 100 watt brake resistor.
Mm.
So currently we have a metal short. We're going to take this out, and we're going to wire in our brake resistor, and then we have to explain to the driver by modulating its configuration that it's got a brake resistor on it.
Oh, okay.
So brake resistors we don't have them yet, but they're like pretty beefy aluminum encased resistor that can take a lot of heat, and it's actually, in our situation, whenever you're going through really fast stop like high G, that's whenever you're going to need to have it.
Oh, okay.
And so for a Z-axis, which is what we plan to use on the XY stage, we're going to add a Z. For Z-axis, it's really important to do that. So
Because all the mass that's moving, you need to stop it and dump that energy into the resistor.
right,
And that was 60
60
ohms?
ohm and 100 watt.
100 watt. Okay.
Right, so it's a big beefy resistor.
Yeah, so get really hot.
Right, so now let's get back to our planning phase here. And okay, so we need to have the LED side up. So this is the top of the box, this is the bottom box. We need to have the LED side up. And that's an airflow management issue with the logic that's inside these components. This is kind of my representation for my Pi.
That's the Raspberry Pi, which is the
RPI4,
which is the little mini computer that's going to run all of this.
right.
Okay.
And then my current plan is that I need to get the resistors in front of my fan. So we're probably going to be putting them somewhere in this area here. Again, not totally sure. This is our 20 volt, and this is a representation of our.
And this is AC to DC 24 volt power supply.
24 volt DC
powering.
coming out of this.
Okay.
And it'll be serviced by the 220 wall plug.
Okay. And the 24 volt power supply is needed for some of the sensors and the Raspberry Pi.
So the 24 volt will be downstepped to a 5 volt. You don't see it here, but there's going to be a downstep. And then this is our optical isolators, which I have near the top of the box. And the reason, so you don't want your 220 AC super close to your signal lines, which I'm going to try to keep up here.
Oh, okay.
Because you don't want the noise crosstalk. But these, I haven't got them out for cleanliness reasons, but basically what this does is it's an optical isolator, so that you can put in your 3.3 from the RPI4, and you can get
And that's
out
from the Raspberry Pi.
yeah,
right?
and then you can get out your 24 volt signal. Anyway, we're taking a lot of care to make sure that we have the control circuit isolated optically from our heavy duty power circuit or service to the driver and motor circuit.
with these optical isolators.
Right.
Which converts electricity into light, and then the light hits a receiver, and the receiver turns the light back into electricity, so that the noise stays isolated with your sensitive electronics.
We're going to be servicing optical sensors, and we're going to be servicing inductive sensors with that 24 volt.
Oh, okay, so that's a safe way to turn the 3.3 volt logic from the Raspberry Pi into 24 volt outputs. Oh,
right.
Okay.
Right, and this is the powerhouse that's going to be driving the 24 volt signal outbound.
Right. Okay.
Okay, so that's kind of where we're at. We're trying to get.
And the 24 volts works with a lot of the sensors that are.
Yeah.
Okay.
Industrial sensors, yeah.
Like,
That's
like limit switches and part and gripper And the gripper solenoid itself is 24 volts.
Yeah, so that's...
The air cylinder, or air valve that we're going to use. Okay.
Yeah, usually whenever you're dealing with injection molders or KUKA robots, or everybody does 24 volt for their their controls, right?
Yeah.
So really, these optical switches are just keeping my Pi safe, and you know, the 5 volt service and 3 volt control. This is kind of what makes it happen for the Pi. Okay. So what we're not doing is we're not using like a formal PLC, and we're not using like a big huge CNC circuit, you know, like a circuit board that's designed for CNC. We're gonna run this out of the Pi because we're doing this on the cheap.
And you're going to actually write the control software.
Yeah.
And the GUI, the user interface and all of that, right?
Right.
Cool. Well, that'll be fun to see.
So I think, okay, so we kind of went through the strategy with the air. We went through the strategy with the sensor signals coming out the top.
Oh, and then these are your handles that you added, right?
Oh, yeah. So this is, you can probably see it move, but you can see the plate that I'm going to be drilling holes into to get all the things mounted. You know, with my hands, I couldn't, you know, putting your fingernail underneath there.
There's going to be a lot of weight on this.
Right. So I put handles on this just because it's going to make my life easier.
That's cool.
Yeah. I thought so. Okay, so maybe let's do a quick calculation. I want to walk the audience through the math for looking at the airflow.
Okay.
So let's see, I've got some notes. If you see me looking down, that's because I've got notes. So these guys right here, the S2 SVD20s, they run...
And that's the drivers for the motors, the servo motors for the main axes of the robot.
Yeah, they run at about 5 to 6 watts. They've also got the power service out to the motor. But anyway, 5 to 6 watts. The RPI 4 is in the 7 watt range.
And that's the Raspberry Pi.
Yeah.
Okay.
So then the 20 volt is in the 3 to 6 watt, depending on what's going on inside the box. And so we've got like little electronics running around too. Yeah. So we're going to round this up to about 30 watt. And really this fan, this fan will plug into the 220. And I'll have to route that around very carefully.
And this was surplus that I got years ago. These were all free. I think we picked these on the side of the road during the bulk cleanup in Santa Clara.
Yeah, well.
There was a whole stack of these that some old tech guy threw out.
Well.
Anyway.
Doing robots on the cheap. Okay.
Yep.
But anyway, so this
those are the motors?
Yeah.
Yeah, okay.
So so basically, okay, so we said we had about 30 watts all the way around. This fan is going to do about 70 CFM. And we want to actually keep, so this box is going to be on top of the injection motor, like I've said a couple times. So we actually want to keep the box closest to ambient as we can.
Right.
So our goal here is to keep it like 1 to 2 degree. We want to stay in the 1 to 2 degree range.
Okay.
So we have a B-feet 70 CFM. And so whenever we want it, I said that we needed to have aluminum mesh right here.
Yeah.
So that takes out 35%.
And the mesh is to keep the
particles
dust and particles from contaminating everything inside of the box.
Right.
Okay.
So so the mesh steals about 35% or so, up to 50% depending on how you do your screens.
Yeah.
So the 70 CFM and the 5-inch diameter, that gives you about 19.6 square inch. And so if you take into account the 35% that the mesh is going to steal, you need 30 plus square inch. So we're gonna actually overdo it just a little bit, where we're gonna get 35.6 inch for 2 of the 4.1 by 4.1. So we're gonna go. Basically, I don't want to starve my fan.
Yeah.
I want to make sure that I'm getting enough out of the intake, that the fan is properly serviced.
Cool.
And basically, there's kind of like a calculation that you can do for with air flowing through a confined space like a box, and 3.16 times the 70 CFM divided by the 30 watt. I think. I'll have to check that. We could put a little thing in the...
Okay.
Okay, so this is a push to connect connector that will be connecting the driver with the motor.
Okay.
So the electrical power that the driver is going to source to the motor will go through this connection and these wiring. And since I have little hands just to hold it, there's some fragile plastic you don't want to push too hard. I've got a little bitty screwdriver. In order to actuate the push to connect, you put your screwdriver in there, and this is closed, and this is open.
Oh, okay, I see it open there.
Yeah. So basically the jaw is open. This is earth ground. We're going to stick the connector part into the hole, and I have to see it from the side. So we got it open. Okay.
All right, there we go.
So the red part should be flush with the black, and then you remove the screwdriver, and you can tell that you got it in there pretty well.
Okay, so there's a spring-loaded jaw in there that you deactivated by prying up through that hole.
Right.
Okay.
So I'm going to do another one just for demo here, where I'm going to open that jaw, stick the connector into the opening. That's,
Yeah.
and then
Crimp terminated wire.
I'm going to check from the side that it's in there, and then let go. And
Oh,
you
nice.
can see pulling up, it's in there. We're plugging in this push to connect connector. Goes in this direction. Okay, we're going to loosely kind of put that in. This has a little triangle part.
This is the wire going from the motor controller to the stepper motor?
Yeah.
Or a servo motor? I think these are servo, aren't they?
Yes.
Cool.
So yeah, these are the drivers. This big, huge, beefy thing. These are the motors. We've got
Right.
3 of them because we're going to do X, Y, Z, X, Y, Z.
Hello, Sierra. How you doing? I'm gonna go outside. Okay, I think this will be a wrap for this video. At least part 1 of many parts for this Cartesian robot rebuild for the injection molding machine. Also, a few other updates is some friends of mine in the local bug group in Silicon Valley have assisted me in bringing the Volkswagen thing back to life. And it's also no longer in the shop, but it's back in the garage. So I've got more room to build out the injection molding automation in the warehouse of Dragonfly Engineering. Also, for those longtime viewers, the garage project, which for those who don't recall, the neighbors called in a code violation on me, and I had to basically turn this garage into or fix the issues of the garage, and then basically started on its way to becoming a second house. So I got final sign off because it's still a garage, so I didn't have to have finished paint or anything. And yeah, so I'm moving some of the stuff that's in the warehouse of Dragonfly Engineering back. For instance, the table saw is there, and a bandsaw, and the Volkswagen thing. So we can do a quick tour of the garage that's signed off and no longer a hassle from the city. So I'll flip the camera around. All right, here we are. So you can still see the trenches I dug for the sewer pipe because I added water and sewer to this structure, again, for it to become a house one day. And then the water pipe, which goes over there. And got a brand new concrete floor that we did in another episode. And yeah, so here's the tour. This structure is original. There's only about 10% of the original garage remaining. For instance, like this foundation's on the property line, so I couldn't actually alter that foundation, but we side pinned and rebarred in a whole new garage floor, and some of the original siding that's now buried in this fire rated wall is still there.
Here to a big this way here, and he's actually breaking the post. He's compromising our post over here. We just recently replaced the post. And
I don't see any damage on the post. It's the dirt.
no, but from here over here, see over here. I don't know why he's digging on the side over here, but over here.
but I restudded the wall, put a new outside metal, I guess basically metal siding on the outside, again for fire safety. And yeah, some of this wall is original from here to there. Behind the drywall was original structure from 1930. And otherwise, oh, and then like the roof is sort of, actually most of the roof is no longer original either, just these cross beams, which actually was made originally from recycled wood from a house that burned down in like the late 1800s. So you can see the char and you can see the plaster lath stripes from pre-drywall construction techniques. Anyway, there's the power box all filled out. And yeah, since this is a garage, again, it's not totally finished, but I think the city inspectors took pity on me because of all the hassle from the neighbors. So yeah, this is where we're at. This is the gas heater for the Volkswagen thing. It actually goes in the front, and this thing actually pulls gasoline from the gas tank. And with this ignition system, which I think is basically just a spark plug, it pulls air in, burns gasoline, and then pipes the hot air into the passenger compartment of the Volkswagen thing. Yeah, and then the exhaust from burning the gasoline pumps out through a hole in the wheel well down here. So yeah, and then this is the addition to the garage, and I have just enough of a sink or a kitchen to pass final inspection. It's funny, the planning department said this cannot be habitable at all because it's not a house, it's a garage. But when the building inspector showed up, he told me to put a kitchen in because that was my plan anyway. So we have all the outlets for a kitchen, including a stove outlet on the floor, which is going to work with the kiln to treat metal and, I don't know, do any ceramic work that I plan on. And then when the guy said, I'll make it a full kitchen, that meant hot water. So I wound up having to put a whole hot water heater into the garage future kitchen, as well as a dishwasher hookup. And of course, you know, the counter doesn't quite make it. But again, I just needed to get the code violation and the building inspection closed. So here we are. Let's go and start up the thing, if you don't mind. So you can hear this awesome engine. I guess we'll take a quick look at the engine first. There it is. This engine actually came off of a bug. So the thing actually has different ventilation schemes. So on a bug, you actually get heat from the engine itself. This is an air-cooled engine, so there's a big air impeller behind this green shroud. And on bugs and buses and stuff, the hot air would come out, but since the thing has a gas heater, that thing, that goes in the front, I basically had to cap these air ports so that we get better cooling on the engine cylinder, which is behind this guy. So yeah, let's start her up. You can hear this engine purr. And then we'll see you guys next week for more of the robot build for the injection molding machine. Gotta make sure that we're in neutral, e-stop's on, because this is a manual transmission. There we go. Thanks for watching Dragonfly Engineering. See you guys next week.